Located on the Central Coast with around 21,000 students and 3,000 faculty and staff, California Polytechnic State University makes up the primary source of transportation demand in all of San Luis Obispo County. In order to facilitate its population of 24,000, the university has implemented different forms of transportation infrastructure with varying degrees of success. Some of the university's greatest strengths include its regional connections, public bus system, cycling infrastructure, and subsidy programs. For example, the city of SLO boasts a regional airport, Amtrak station, and numerous long bus routes that service San Jose, for example. In addition, the university won a bronze level cycling award for its bike infrastructure and friendliness. In addition, the public bus is a popular choice among students due to subsidy programs that make it free and also due to the fact that numerous stops permeate the campus. But unfortunately, there are also numerous issues with Cal Poly's transit system. For one, the hilly topography of the area makes it difficult for the campus to expand and is also a negative factor in walking and biking on campus. Also, the campus has a lack of parking for personal vehicle use. This forces student permits to be extremely expensive, averaging around $660 for the academic year. Despite this, Cal Poly wishes to expand residency by 4,000 students by 2035, while only adding 174 more on-campus parking spots. They primarily hope to accomplish this by increasing the attractiveness of on-campus transport through walking, cycling, and public transport rather than personal vehicle use. In order to solve these transportation issues and improve their efficiency, the university must employ smart technologies in order to do more with less. In order to understand how to tackle these transportation-related issues, we'll take a look at successful projects from around the globe. Each of these case studies reveal how live data tracking and real-time responses can allow infrastructure to function at a much more efficient yet less resource-intensive pace. Our first case study is Smart City, Ohio, which exemplifies the benefits of an interconnected and autonomous transport system. The city of Columbus, Ohio employs electric autonomous vehicles, multimodal trip planning applications, an autonomous shuttle, and mobility services for people with cognitive disabilities. While all of these pieces of infrastructure help people move around the city, their most valuable asset is the data-driven insight they attain based on users' transportation patterns. Similar to the Smart City Ohio initiative, the Smart Streetlights program specializes in data collection, but uses its autonomous nature to work 24/7. Through this comprehensive collection, streetlight metrics can create a comprehensive understanding of a city's transportation patterns, which in turn can be used to facilitate smart city elements such as detailed greenhouse gas emissions, VMT models, rideshare services, and social equity and travel demand management. So far, streetlight data has experienced great success in the city of Toronto, especially in interpreting on how the city can save on trips. While the previous two case studies focus on vehicle patterns, the Starling CV Smart Crossings project uses transportation data to protect cyclists and pedestrians. The project by Ubrelium aims to redesign the traditional pedestrian crossing by implementing dynamic LED panels which function in accordance with cameras that identify cyclists, vehicles, and pedestrians. With the help of traffic pattern data and augmented VR, these smart crosswalks will increase pedestrian safety and walkability in cities. Lastly, the implementation of revolutionary transport technologies such as autonomous vehicles and parking management apps will certainly change how cities function, and Cal Poly can certainly learn how to better their transport environment by examining cities employing such technologies. By examining the technologies and methods utilized in the previous case studies, we can better understand how to solve the transportation problems that afflict Cal Poly's campus. One of Cal Poly's biggest transportation problems on campus is its inefficiency when it comes to parking. Currently, the university only has 2,922 parking spaces allocated for students, and 7,550 parking passes are distributed quarterly to students for these spaces. Clearly, the number of parking passes exceeds available space, and the university's current strategy is to simply build more parking. This could be much better solved with an app that better connects students to parking spaces and makes them function at a much more efficient level. For example, such an app could allow a student to reserve a parking space ahead of time or announce that they're about to leave a parking space so that another student can quickly find a spot for their car. For those without access to a personal vehicle, Cal Poly must do a better job at integrating technology to offer better shared transport. One possible solution for the university would be the inclusion of 3D printed shuttles, such as Ollie, designed by Local Motors. A major benefit to these shuttles is the fact that they use RFID trackers and 3D printing to remain fully autonomous yet cost effective. Additionally, pickup and drop off through these shuttles can be managed entirely through an app and is highly flexible when compared to public transport systems. For example, late at night, a student could request a shuttle service to bring them back to their apartment instead of having to call a friend or a taxi to bring them back since public transport doesn't operate late. Should students prefer a more individual form of transport, Cal Poly could offer an app that allows students to rent and share bikes, akin to Lime or Bird scooters. In turn, Cal Poly could gather valuable data by examining renter tendencies and traveler patterns through such apps. By creating an app that better connects existing resources, Cal Poly can create a more connected and efficient environment for transportation. It appears that the best way for Cal Poly to transition into a digital campus would be the introduction of apps to keep track of existing assets and processes. The best thing about digital infrastructure is how adaptable and applicable it is, and so this technology can be integrated in numerous different ways. Examples include a healthcare app that could be available to students so that they could see a doctor and get a professional opinion or simply look up their symptoms. Another app could include a parking management app where a student could reserve a space before they're about to arrive on campus or announce that they're about to leave so that another student could take it. Or even a social app that could better connect students on campus and encourage them to stay on campus for social activities rather than go into surrounding cities for entertainment. The university could further integrate new technologies by cultivating a collaborative digital culture. For example, programs that would allow students to upload their projects and collaborate with other majors would allow students to work on a much more efficient and larger scale. For example, a city planning major could upload their site plan and give it to a fellow architecture student, in which they could look into it and possibly develop renderings and return it to the city planning student, and vice versa. This would allow majors to communicate and exchange info. This concept could even be applied to professors who would be able to upload their lectures or notes and share them with fellow faculty members to create a more comprehensive environment on ideal teaching styles and previously covered material within the major or even outside other majors. By starting with the creations of these apps and connected collaborative services, Cal Poly can take its first steps to becoming a digital campus and serving as a model for the future.